We've got three numbers in standard form that form this equation. We're asked which of the following must be true. Now let's just go back to the standard form. If something to be in standard form, the A, B, and the C, they have to be greater or equal to 1. It can't be below 1 because then it wouldn't be in standard form. Like 0.6 times 10 to the 8, it's not in standard form. You'd have to write it as 6 times 10 to the 7. Then it is. So A, B, and C are all greater or equal to 1, then they've got to be less than 10. Because if they were, say, 10 times 10 to the 9, actually, you can write that as 1 times 10 to the 10. So this number, yeah, between 1 and 10, but not including 10. Okay, just going to bear that in mind throughout. Now, we've got this equation, just to make it a little bit simpler, 10 to the minus 3 is actually 1 over 1,000. So I'm going to times through by 1,000. 10 plus, sorry, A plus 10B is going to equal 100C. That is going to be easier to deal with. So I've got these two conditions, and now I'm going to look at the statements and whether they're true or not. So the first thing I'm going to try and do is find counterexamples to each one. That just seems like a good way to go. Does A have to be greater than 9? Okay, well, let's say that C was equal to 1. Then I could have B equal to 9.9, no problem with that. And then I would get A plus 99 equals 100, so A could equal 1. So that one doesn't have to be true. And before I look at the second one, I'm just very quickly going to look at the third and the fourth. So for the third one, it says A has to be less than C, but in my earlier counterexample, I got a situation where they're equal. That worked. We had 1 plus 99 equaled 100, no problem. And actually, this one's not true either because B was 9.9 there and C was 1. So because there's no option that says none of them are true, our answer's got to be 2 just by looking at that. But let's convince ourselves that it is. Okay, B greater than 9. So what if B was less than 9? Maybe I could let it just make it equal to 9 point actually let's just make it equal to 9 because then if I can show that there's a problem, I know it would have to be greater than 9. So if B was equal to 9, I would get A plus 90 equals 100C. Now the smallest C could equal is 1, as we saw from before, so we'd have to have A plus 90 is greater or equal to 100. But that would mean that A has to be greater or equal to 10, which it can't be because we know it's less than 10. So basically it has to be true that B is greater than 9. Let me just have a go at finding the lower bound of B. Right, so this would be a slightly more rigorous proof, or we could rearrange it. So 10B is equal to 100C minus A. So B is 100C minus A over 10. And therefore B is going to have to be greater or equal to the smallest value of C, which is 1, minus the highest value of A, because that's how I'm trying to get the lower bound here. So I want to use the lowest value of this and the highest value of this. So A would be like 9. I mean, there is no higher value here. So actually I can change it to a 10 and say that B has to be bigger than that. So 100 minus 10 over 10, and that actually gives me 9. So I've kind of proven it here, not just use that. So yeah, B will have to be greater than 9. It's statement 2 that is necessarily true.